Session 1.5, Collecting Data to Understand Causality. Okay, studying causality. Question about causality. We like to use like what if something happened like that. For example, I would say, what if I take this medicine? Will I get better? So this is a causality questions. Like if I take this medicine, so this is gonna be the treatment. And then the outcome, what's gonna be the outcome? Will I be getting better? That will be the outcome variable. So we use to collect the data to determine what types of conclusion we can make. Okay, so we do have first the treatment variable, whether or not a specific treatment is used. This is the cause, right? And then the outcome, or you could say this is a response variable, whether or not a certain outcome is seen. So one more time, causality, you do have a treatment and you do have the outcome. So we are trying to see, we want to see the goal to determine if the treatment variable cause a change in the outcome variable. For example, if you want to know whether a certain diet aid works, you should work on. If the diet A was given, this is the treatment variable. And what is the result? Result of weight loss. Okay, so this is gonna be outcome variable. So we want to see whether the treatment variable cause change in the outcome variable. Okay, treatment and control group. The treatment group, talking about the group that received the treatment or has the characteristic of interest. The control group that does not receive the treatment or does not have the characteristic of interest. So I will use the example to explain these two guys, and also the placebo. Placebo means it looks like drug, but there's no medical effect. And then placebo effect, reacting to a treatment after being told you are receiving the treatment when in fact you're not. Okay, let me use the example to explain these four terms here. Okay, in the experiment, we do have a one treatment group. We do have 200,745 children. Okay, in this group, and we call this is going to be the treatment group. And then for this treatment group, they gonna insert the shot vaccine. Okay, all these children will receive the shot vaccine. Okay, that's to prevent the polio injections. And then there's another group. We call this is gonna be the control group. And for this group, we do have 201,229 children here. And for this group, they gonna inject the placebo. Remember what is a placebo? Placebo means it looks like the drugs, but there's no medical effect. And then the children being injected did not know whether they were getting the shot vaccine or the placebo. Okay, so you can see why we have these two groups in here. This is the treatment group. We want to test the shot vaccine if it's gonna be working for those children. And then the control group, they only inject the placebo. It looks like the drugs, but there's no medical effects in here. And then at the end, I don't know like how long, how many days, or how many months, they will compare the result. And we call this is going to be the treatment and the control group in here. Okay, so here, this is a treatment group and this is the control group. And then they inject the placebo here. Control experiment. So this is the control experiment in here, and children are randomly assigned on each group. Usually we'll be using the technology. For example, we do have a whole bunch of the name of the children here. We input it in the computer, and we use the computer randomly assigning the subject to the treatment group or to the control group. Okay? Writing, independent party assign subjects to a treatment group. So maybe only the daughter who knows who gonna receive the shot vaccine, who gonna receive the placebo. So this is gonna blinding test. Double blinding means even like the daughter, the nurse, or the children, they don't know who gonna receive the placebo, who gonna receive the shot vaccine. If possible, we usually will be holding the double blinding experiment. Okay? Anecdotal evidence, a story based on someone else's experience. I would tell you guys from my experience as a professor more than 10 years, if the students always come to class on time, pay attention to my lecture, write down the notes and turn in the homework, usually that students will get A or B. So this is anecdotal evidence. Observational study. Subject placed into different groups by choice or someone else. Okay, what is observational study? For example, I will have a two group of the people. One group is the smokers and one group is non-smokers. Okay, I will have a whole bunch of the people in these two groups. Observational means I only observe these two groups of the people. We don't attempt to do any treatment. Okay, I only observe it, maybe like I only observe them like 30 years. Okay, so after 30 years, I will find out, oh, this group, they do have a 30% of the people has the lung cancer. And for this group, they may only have 10% of the people get the lung cancer. Keep in mind, observational study is only observe, okay? You don't attempt to make any changes for them. Okay, so after 30 years, 30% of the people in this group to get the lung cancer. And this group, only like 10% of them only get the lung cancer. Okay, so since this is observational study, never point to causality, the cause and effect. Since this is observational study, you can't draw the conclusion saying that smoking habit will cause you to get the lung cancer. You can't make like this kind of the conclusion because this is observational study. You only can say smoking habit is associated with the lung cancer. Okay, you can't say this is a cause, something happened, because this is observational study. If you want to establish the cause and effect, you will use the control experiment. Okay, control experiment. Okay, for example, causality. If you notice that when there are long lines going to the beach, the number of ice cream sales go up. That does not mean that the long lines to the beach are causing the increase in ice cream sale. Okay, even though you will think like this way, oh, because today is too hot and that's why more people want to eat ice cream, but you can't say this is cause and effect. If you draw this kind of the conclusion, we will say this is a misleading conclusion. Okay, one more time, this is observational study. So you only can draw the conclusion saying that there is association between the long lines going to the beach and the number of ice cream sales go up. They are associated to each other, but it doesn't mean something caused, something happened like that way. Okay? Confounding occurs in an experiment when the investigators are not able to distinguish among the effects of different factors. For example, when I'm stressed, I get the muscle cramps. However, when I'm stressed, I also drink coffee and lose sleep. So it's hard to tell whether my cramps are caused by the coffee, lack of sleep, stress, or some combination of the above. So we call this as confounding. Okay, gold standing in experiment, large sample size. Okay, every time when we want to do the experiment, we want to get the large sample size. And then assignment to the treatment or control group is random, controlled by the researcher. Usually we'll be using the technology, using the computer randomly to pick the people. Placebo is used, is appropriate. Study is double blind, means no one knows which one is the treatment group, which one is going to be control group. Okay, for this page, I want you guys try to read the book by yourself. That will be on the book, page 24 to 25. Remember, if you guys purchase the access code, they come with the e-test book. So you could go on the Pearson website, or you could click on your Canvas, the Open My Lab and Mastering, and then we direct to link to the My Pearson account. You should find the e-test book from there. If you don't remember how to do it, feel free to watch the video, the syllabus and course information video. I showed it to you guys already from there. That's it, session 1.5.